Good day guys, my name is Nico from Explain Tutorial, and today we are going to be treating this topic motion under post-SEMI, JAMB post-SEMI students. Okay, we're going to be starting with the normal linear motion as we know it. The normal linear motion, that is the normal motion on a straight line. Therefore, we have terms that we usually define that motion. We usually talking about terms, talk about speed, we talk about velocity, and we talk about what? Acceleration. That is speed, velocity, and acceleration. Now we're going to be defining these terms. Now, speed, speed, speed. Speed is the rate of change in distance with time. Speed is the rate of change in distance with what? Time. Is the rate of change in distance with time. While velocity is the rate of change of displacement. Rate of change of displacement with what? Time. So speed is the rate of change of distance with time. Velocity is the rate of change of what? Displacement with time. While acceleration is what? The rate of change of velocity with time. Okay, under all these concepts, we have uniform velocity, we have uniform acceleration, we have average speeds, and the rest will come into them as we move on. Now, uniform velocity, when the rate of displacement of a body changes with time at equal intervals, means the velocity of that body was uniform. Let's say they said the body has a uniform velocity of 3 meters per second. That means the body moved every second, the body has moved 3 meters every second. The next set 3 meters, it has moved in another 1 second. That means it moved 6 meters in what? 2 seconds. So this velocity is uniform. And note, when the velocity of the body is uniform, the acceleration of the body is equals to what? 0. When the velocity of the body is uniform, the acceleration of the body is equals to what? 0. Okay, let's talk about some of the equations of motion. We know we have the following equations of motion. We have V is equals to U plus AT. We also have V squared is equals to U squared plus 2AS. Then we also have S is equals to UT plus 1 over 2AT squared. Then lastly, we have S is equals to U plus V over 2 all times what? T. These are very popular equations to all of us. Now let me explain the terms. V is equals to final velocity. V is equals to final what? Velocity. U is equals to initial velocity. T is equals to time. And what? S is equals to distance. What other parameter do we have? Then A is equals to acceleration. So these are the parameters. Now let me explain some few concepts under these parameters. Now, when a body starts from rest, what does that mean? When the body initial velocity, when it starts from rest, it means the initial velocity of the body is equals to what? 0 meters per second. When a body comes to rest, the final velocity is equals to what? Final velocity is equals to 0 meters per second. Now, when the body moves to uniform velocity, we've explained that before, the acceleration of the body is equal to 0 meters per second squared. So these are the parameters we should note when talking about motion. Also, I would also like to talk about another thing. When the body starts from rest, the acceleration is 0 meters per second. When it goes to rest, the velocity is 0 meters per second. Then when it's at most uniform velocity, the acceleration is 0 meter per second square. Now, let's take a question. Let's illustrate something with a question. Let's say a body starts from rest and attains a velocity of 5 meter per second in 10 seconds. Calculate the body's acceleration. Now let's take a look at this question. A body starts from rest and attains a velocity of 5 meter per second in 10 seconds. Calculate the body's what? Acceleration. So this is a very easy and simple concept. Now, a body starts from what? Rest. U is equal to 0 meter per what? Second. And attains a velocity of 5 meter per second in 10 seconds. The final velocity is what? 5 meter per second. The time is equal to what? 10 seconds. Calculate the body's what? Acceleration. Calculate the what? Calculate the body's acceleration. So we're looking for A is equal to 1. Now if you look at all these parameters, the one that fit in the most is our first equation of motion. From our first equation of motion, we know that V is equal to U plus AT. Then we know that V is 5. So 5 is equal to U 0, 0 plus A is unknown, A T is 10 times 10. So we know that 5 is equal to 0 plus 10A is 10A. We know that if 5 is equal to 10A, then A is equal to what? 5 over 10. A is equal to 0.5 meter per second what? Square. So this is just a solution to this problem. It's very easy, very simple. So you just have to apply all these concepts. Now let's take another question. The question says a body starts from rest and moves with uniform velocity of 5 meter per second for 10 seconds. Calculate its acceleration. Now this question is very similar to the first, but note I said a body starts from rest and moves with uniform velocity of 5 meter per second for 10 seconds. Now the body is moving with uniform velocity, so the acceleration is equal to 0 meter per second square, because the body is moving with what? Uniform velocity. So there's no need to solve. Because the body is moving with uniform velocity. That means the velocity of the body does not change. When body moves with uniform velocity, the velocity of the body does. The velocity of the body is constant with time. That means for every equal time interval, the velocity of that body for every equal time interval is the same. So the acceleration is not also changing with time, because for acceleration to take place, the velocity has to change with time. That means for acceleration to take place, there has to be a change of velocity with time. But this does not occur because velocity is what? Constant. So even if acceleration is taking place, then we now have V minus U over T, because this is initial, this is final, right? Now because the velocity is not changing with time, meaning V is equals to U. So if you substitute this, now have V minus V over T, which is 0 over T. And we know that 0 over T is equals to what? 0. So that means the acceleration of a body does not change with what? It does not change with time, because of the fact that it has uniform velocity. Okay, now let's take another question. Let's take another question on tradition. Let's say a body starts with an initial velocity of 10 meter per second and comes to rest in 5 seconds. Calculate the body's retardation. Now notice when the body is coming to rest, the body is retarding, right? So we already know that V is equal to 0. V is equal to 0. And we already know that U is equal to 10 meters per second. And we already know that T is equal to 5 seconds. Now note this. Now when a body is coming to rest, our equations of motion will change a little bit. Though remember our equations of motion, we had V is equal to U plus AT. But because of retardation, this will change to V is equal to U minus AT. The same thing will happen to all other equations of motion. Remember we had S is equal to UT plus 1 over 2 AT squared. But if you have a concept of retardation, this plus will change to minus, meaning under retardation, under conditions of a body coming to rest, that plus will change to what? Minus. We also had V squared is equal to U squared plus 2AS. So under conditions of retardation, this plus also returns to what? Minus. Note, nothing will happen to the equation that we had. Remember that equation we had? S is equal to U plus V over 2T. Nothing will happen. This plus does not change to negative because there is no acceleration in this equation. Now the plus is changing to negative because of the fact that retardation is equal to minus what? Acceleration. Just replace this into any of our initial equations and you will get that this positive was actually changing to what? Negative. So that is just the concept of retardation. Okay, since we have gotten the concept of retardation here, now we know that the body is retarding. All we have to do is to just bring in our formula. Remember that V is equal to U minus AT now because the body is retarding. V is 0, U is 10, T is 5. So we now have 0 is equal to 10 minus what? 5A. So we now have collect like terms, 5A is equal to 10, then A is equal to A is equal to 10 over 5, A is equal to 2 meters per second square. So this is it. This just is. Under the concept of retardation, the positive will change to what? Negative. Now let's take another question. Let's take a question that has to do with conversion. Let's take a question like this. Calculate the distance covered by a body with an initial velocity of 33.6 km/h if it accelerates at a rate of 2 meters per second square for 4 seconds. Okay, so this is a question that has to do with what? Conversion. Calculate the distance covered by a body with an initial velocity of 3.6 km/h if it accelerates at a rate of 2 meters per second square for 4 seconds. Now you know that the velocity of the body was given in terms of what? Km/h. So we can't actually work with this because we need to convert to suitable unit that go with the rest of the question. We are working with meter per second square and working with what? Seconds. Now note, to convert from kilometer to hour, from kilometer per hour to meter per second, from kilometer per hour to meter per second, you divide by 3.6. Divide by what? 3.6. So to convert any value from kilometer per hour to meter per second, divide by what? 3.6. But to convert from meter per second, to kilometer per hour, we just do the opposite. We multiply by 3.6. So to convert from kilometer per hour to meter per second, we divide by 3.6. To convert from meter per second to kilometer per hour, what? We multiply by what? 3.6. So how do we so now how do we convert? Okay, the question, you know the question. So how do we convert? So remember the question said the body starts from the body starts with a velocity of 3.6 kilometer per hour, and the body accelerates at a rate of 2 meter per second square for 4 seconds. So these are our parameters. So first of all, we convert this velocity to meter per second. Converting it, we know the u is equals to 3.6 kilometer per hour. So we can just simply divide this one by 3.6. We'll have what? 1 meter per second. Now, acceleration is equals to 2 meter per second square. Time is equals to 4 seconds. Now, we're looking for what? Distance. Now, if you have guessed correct, that we're using the equation of motion that goes like this. S is equals to ut plus 1 over 2 at squared. Then you are very correct. So we'll substitute everything into this equation. Then we'll have that S will be equals to 3.6. S will be equals to 3.6 times time is 4. 3.6. Sorry, we're now working with meter per second. So S will be equals to 1 times 4. 1 times 4 plus 1 over 2. Acceleration is 2 times 2. In mathematics, dot sign also means multiplication. Times 2, then times 4 squared. So that will give us 1 times 4 is what? 1 times 4, that will give us 4. 1 times 4 equals 4. Then plus 1 over 2 times 2 is 1. 4 squared is 16 plus 16. That will be equals to 20 meter. Okay, now let me place a practice question on the board. Let me place a practice question on the board for you guys to try. A practice question on the board for you guys to try. Okay, let's have this question. A body starts from rest and accelerates at a rate. The body starts from rest and accelerates at a rate of 4 meter per second square to a velocity of 7.2 kilometer per hour. 7.2 kilometer per hour. The question we have is calculate the total distance covered. Okay, let's say we have these questions, the practice questions. You guys should try it. I'll be back in a bit. Okay, I'm back. Let's try and solve this question now. The body starts from rest and accelerates at a rate of 4 meter per second square to a velocity of 7.2 km per hour. Calculate the total distance covered. Now we have many parameters here. We have like the body accelerates at a rate. So we know that acceleration is equals to 4 meter per second square. The velocity is equals to 7.2 km per hour. So we know that what we're supposed to do is to convert this to meter per second. So divide this by 3.6, which will give us 2 meter per second. Now they say we should calculate the total distance covered. Now remember the body starting from rest. So u is equals to 0 meter per second. Now the equation we use here, the equation we're going to use here, we're going to be using the equation. We're going to be using the equation v squared is equals to u squared plus 2as. Now what is our v? 2 all square is equals to 0 all square plus 2 into, what is our acceleration? 4. We're looking for what? S. So how about 4 is equals to 0 plus 2 times 4, 8s. So we have 8s is equals to 8s is equals to 4, s is equals to 4 over 8 is equals to 0.51 meter. So the distance covered by the body in this period was 0.5 meter. That means the body covered the distance of 0.5 meter during that particular motion. So if you got 0.5, you are very what? Correct. Now I want to put another question on the board, a very nice question before we go into other concepts of motion. Now let's look at this question. Let's say if the velocities of a body at points A and B are 10 and let's use 12 are 12 and 14 meter per second square, 12 and 14 meter per second, 12 and 14 meter per second respectively. Let's see we have this, and it said calculate the body's velocity at midpoints. Now let's say we have a question like this. The velocity of a body points A and B at 12 or 14 meters per second respectively. Calculate the body's velocity at what? Midpoints. Let's have a diagram. Let's say we have a diagram like this. This is A, this is B. They said the velocity here is 12 meters per second. They said the velocity here is 14 meters per second. What they are asking us to do is to find the velocity at the midpoint. Now, majority of us will just simply go and do 12 plus 14 divided by 2. That will be 12 plus 14 divided by 2. 12 plus 14 is what? 26 divided by 2. And a lot of us will be getting 13. Of course, that will be very wrong. Now, there's a velocity formula for calculating velocity at midpoint. And the formula says the velocity at midpoint, midway velocity at midpoint is equals to the square root of the final velocity square plus the initial velocity square all over 2. So that will give us that the v midway is equals to the square root of what is v? 14 square plus 12 square all over 2. That should give us what? Somebody should calculate this. What is 14 square? 14 square should be 196, then plus 144 all over 2. Add this and this. That should give us 196 plus 144. That will give us 0 here. 0 plus 10, 14. 0 plus 1 plus 9 is 10. That is 10 plus 4 is 14. 1, 1, 2, 3, 3. That should give us square root of 340 over 2. That should give us square root of 340 divided by 2. 340 divided by 2 is 170. That should give us 13 point something. 30 point something, and that will be very accurate. That will be the word answer. That will be the answer to the word question. So this is the formula for midway velocity. Please take note of it. Now we're going to be looking at another concept, and to introduce that concept, I'm going to be bringing a word question. To introduce that concept, I'm going to be bringing a word question. Now let's say we have a concept like, a body starts from rest and accelerates at a rate of 2 meters per second square. Calculate the distance covered in the 10 seconds of motion. Let's say we have this. A body starts from rest and accelerates at a rate of 2 meters per second square Calculate the distance covered in the third second of motion. Now, anytime we see questions like this, we reference to time that have the suffix third, second, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th. They have this particular suffix or is it prefix attached to them. That is a particular stuff attached to them. What we usually do, we usually make use of this formula. S is equals to U plus S is equals to U plus 1 over 2a into 2t minus 1. So this is just the formula we'll make use of. Now please make note of this formula. Take note of this formula. Anytime you see them use this suffix, anytime you see them use this particular suffix, third, just try to just try to take note of this formula. Just put this formula in your head and mark it down, because this is formula that is mostly used to solve this kind of questions. Now let's solve this question using this formula. They said the body starts from rest and accelerates at a rate of 2 meters per second square. Calculate the total distance covered in the third what? The total distance covered in the third second of what? Motion. That means we know that the body starts from rest, so we know that u is equals to 0, right? Now we know that the body accelerates at a rate of 2 meters per second square, so acceleration is equals to 2 meters per second square. It's also to calculate the total distance in the third second of motion. So we take t in this particular question now to be 3. So t is equals to 3 seconds. Now all we need to do is to put all this stuff into our equation. So we now have s is equals to u is 0, of course. So that will be 0 plus 1 over 2a into 2t minus 1. Acceleration is 2. 1 over 2 times 2 times, what is t? 3. 2 times 3 is 6. 6 minus 1, 5. 2 here will cancel 2. So s is equals to 1 times 5, 5. 5 plus 0, 5. 2 here is equals to 5 meters. So that will give us the answer to the question. So basically, just take note of this formula anytime you have questions relating to time that have reference to this suffix third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, and so on and so forth. Okay. Now quickly we'll be looking at another concept. So we're looking at the concept of instantaneous velocity and instantaneous what? Acceleration. Instantaneous velocity and what? Instantaneous acceleration. Now let's see, they give us instantaneous velocity is like the velocity of the body at a particular instant of time, while instantaneous acceleration is the acceleration of that body at the same particular what? Instant what? Of time. Now let's say we have something like this. Let's say they give us the distance of a body relating to time. Let's say if the distance covered by a body, in time t is given by s is equals to 3t squared plus 9t. He said calculate the velocity of the body. At t is equals to 3 seconds. Now this is a typical case of instantaneous velocity. Now what we do is we differentiate. We will differentiate this equation. Now you know that when we differentiate distance with time, that is, you know that velocity is equals to what? Change in this displacement over what? Time. Now when we differentiate this, we now get that the velocity of that body is equals to what? The ds over what? Dt. So all we have to do is to differentiate what? This particular what? Equation. Now for those that might not understand the concept of differentiation, let me quickly explain it. Now let's say they give us a particular say something like differentiate 9t squared. What you simply do is this 2, the power on top of the t, use it to multiply the coefficient of the t. That will be 2 times 9 multiplied by the t bar. But instead, that power now, we now remove 1 from it. Now be 2 minus what? 1. That will now be what? 18t. So that is differentiating what? 9t squared. Now let's say we are differentiating something like 4t cubed. The same thing, it follows 3 times 4 times t. Then remove 1 from the word power, 3 minus 1. That will be 12t what? Squared. But let's say I do something like just differentiate something like 2t normally. Differentiate something like 2t normally. Now, when I differentiate something like this normally, when the coefficient when the power on top of the t is just a singular word power, the answer will be equal to 2. Differentiate 9t, 9. Differentiate 20t, 20. Now let's say they said we should differentiate a constant. The constants are the numbers. Now they say differentiate 9, differentiate 3, differentiate 7, differentiate 8, differentiate 10. So this will give us 0, 0, 0, 0, 0. So differentiation of constants, differentiation of numbers are what? Zeros. Now let's go back to the question. They said the distance squared by body is given by 3t squared plus 9t. Calculate the velocity of the body at t equals to what? 3 seconds. Now remember what we do is we differentiate this equation. Now we know that s equals to 3t squared plus 9t. If we differentiate this equation, now velocity is equals to the s over the t, which will be equals to, this will be 2 times 3 is 6, move on from the power, 6t plus what? 9. Now at t equals to 3 seconds, just simply put t as what? 3. That will be 6 into 3 then plus 9. Now it equals to 18 plus 9. Now it equals to 27 meter per second. Now let's say they said calculate the acceleration of the body at the same t equals to 3 seconds. Now you see this equation for velocity, we'll differentiate it again. Because calculating the acceleration of the body means we are differentiating this distance twice. So we just simply differentiate the formula for velocity. So the time you calculate the acceleration of a body, after differentiating distance to get velocity, that velocity equation will differentiate it again to get what? The equation for the what? Acceleration. So it's just like saying if this equation for velocity and want us to find the acceleration, we are just simply going to differentiate this equation now. So let's differentiate it. Differentiate 60 plus 9. So acceleration will be equal to dv over what? dt. Differentiation of 60 is 6. Differentiation of a constant is 0. So acceleration is equal to 6. Just there's no coefficient of t here to put as 3. So the answer is 6 meter per second squared. Now let's imagine that this was 60 squared. Let's just imagine this was 60 squared. And after differentiating, we had 60. Just imagine, after differentiating, we had 60. At the end, we still come and put c as what? 3 seconds. But in this case, it was just 60. So the answer was just what? 6. So that would be the answer for the what? For the acceleration, for instantaneous acceleration. So next, we're going to be looking at velocity time graph. Now, velocity time graph is simply the graph of what? Velocity what? Against time. So velocity time graph of velocity against time. So if we have a graph, let's say, okay, this one is not really. Let's say we have a graph. Let's say we have a graph. Let's say we have a graph. We have a graph like this. We have a graph for velocity time. Graph velocity of time. Of course, my 0 will be here as the origin. Now let's say the body starts from rest. The body starts from rest and accelerates to a certain velocity, for a particular time. The body continues with that velocity for another given period of time, and they accelerate at the end of the total, at the end of everything. Now see something that they can ask you to calculate different parameters in this equation. Now let's say they say calculate the total distance squared by the body. So that distance squared by the body is simply the area of all the shapes in this particular circle. In this place we have 3 shapes. We have shape A, shape B, shape C. So for to calculate the area covered, the total distance, we simply calculate the area of this triangle plus the area of this rectangle plus the area of this triangle. Now you see this line, this steep line is representing the acceleration of the body, while this steep line is representing the acceleration of the body, of course. Now this is the maximum velocity of the body. Now let's treat other cases. Now you know that we can also have different type of graph. Now let's say they give you a question like this. Let's say usually comes when people say it's a very popular question. If the distance squared by body is plotted against the square of time, if the distance squared by body is plotted against the square of the time, and it gives a straight line course coming from the origin. They said, what will be the value of the slope? What will be the value of the slope of this line? Let's say they ask this question like this. Now, let me quickly show you something. Now, remember this is our equation. S is equal to ut plus 1 over 2 at squared. The body starts from rest, so u is 0, so this immediately cuts out this part. So we'll now be left with s is equal to 1 over 2 at squared. Remember our equation of a straight line, y is equal to mx plus c. Now, x is the t squared because it's on the x-axis, y is the s because it's on the vertical axis. So our slope will be equal to half the acceleration. So the value of the slope will be equal to half the acceleration. So that will just be it. So basically, for the velocity graph now, to calculate total distance, calculate the area of the shapes. Area of the triangle is half base times height. This will be the height. From here to here will be the base. Area of this one is length times breadth. This will be the length. This will be the breadth. So this place here will be the word breadth. This one is half base times height. This will be the base. This will be the word height. So that will be how to calculate the total. At the end, we add everything on together. Now they said calculate the average velocity. Average velocity is the total distance over the total what? The final time. The total distance over the what? Total time. So that will be how we calculate the average velocity of a velocity time. That's average velocity of a velocity time graph. So basically that is just some of the wraps of a motion. In our next class, we'll talk about motion under gravity and projectile motion. I'm Yiko. Thanks for watching. Explicit tutorials.